Today we will start doing Chapter 3 review. So Chapter 3 is mostly about decimals, adding, subtracting, multiplying, and dividing. Let's look at these four problems first. We have 4.9 plus 3. When we set up this problem, how is it going to look? Like this? Or like this? So what do we think? Who thinks first one? Raise your hand. Who thinks second one? Raise your hand. Those of you who think second one, you are correct. When you add and subtract decimals, and I suggest you write this down, when you add and subtract decimals, you have to line up the decimal. When you add and subtract decimals, you have to line up the decimal. So in this case, the answer would be 7.9. I saw many of you students putting 5.2 as the answer, which is not true. That's if you didn't line up the decimal. So I want you to do it with the other problems, and then we'll see what answers we get. Okay, Gohar, what's the first step? What do we do? So we're going to first add the 6 plus 3. What do we get? 9. Oops, I'm using the wrong pencil. 9. We do that again. We get 9. What's 5 plus 4? 9. And then what's 1 plus 2? 3. And we just carry down that decimal. That just follows us right down. Okay, Alinza, what about the second one? Technically number 3. So we have to regroup with this bottom one because 0.39 cannot subtract 0.4. So we turn this into a 10. So we turn this into a 2. 10 minus 0. Oops, never mind. We did that one fine. We could do the 9 minus 0, we get 9. 3 minus 4, we turn that into a 13, and this into a 3, as I'm already messing up. 13 minus 4 makes it a 9. We just drop our decimal down. 13 minus 12 is 1. So we get 39.99 for number 2 and 1.99 for number 3. Now, this last one is a little different. We have multiplication. So when we multiply it, how do we set up our decimals then? How does it matter? Who can tell me how we set up our decimals when we multiply? What do we think, Miles? Same way we always did? That's a good guess. Does anybody have any idea? Madison?
No, decimals don't have to line up.
Exactly. With multiplication, the decimals don't have to line up, Madison. So when we set them, what we do is we put them all the way to the right side. We did that in the last one as well. So when we do that, we just move our decimals however many places over, and then at the end, however many places back. So what's 8 times 4? Who can tell me, Michelle? 32. Put the 2 here, 3 here. What's 8 times 2, Emerson?
60.
Perfect. So it becomes 19. We get our answer to be 19.2. Who agrees with that? We give it a thumbs up? Yeah, we give it a nice thumbs up. Now here's technically number 4. It made more sense when looking at the test on paper. So the melting point of sodium is 97.8 degrees. So we think that's a pretty important fact we got right there. The melting point of potassium is that many. How much higher is the melting point of sodium? When we read that question, how much higher, what kind of operation might we be doing, Michelle? Subtraction, exactly. We're trying to find the difference. How much higher is the Empire State Building? We're trying to find the difference. So we have 97.8 and we have 63.65. How should I line these two up? Where is it going to go? How do I line them up, Liam?
Wait till because you'll put 97.8 under 63, but you would have to add 0 to behind the 8.
Yes, although we do put the 63 at the bottom because we are subtracting it, but correct, we put that 0 there so that they all line up. We're subtracting. 0 minus 5, can we do that? 0 minus 5? No, so we got to regroup. We do all of our regrouping. Woo! Regrouping, fun. Excellent. We get 34.15 as our answer. That's why this one was number 4 before number 5, because 5 started our multiplication section. So, for number 6, We have 0.0198 times 75. Now, this one's an interesting problem. It relates to what we've already learned, percents and numbers less than 100% and greater than 100%. Is this first number less than 1 or greater than 1? Less than 1. So are we going to get a number less than 75 or more than 75? Less than 75. When we multiply 75 by 1, we get 75. When we multiply 75 by a number bigger than 1, we get a number bigger than 75. For example, 75 times 2 is 150, bigger. So when we multiply something by a number less than 1, it's going to result in a smaller number. Once again, all we got to do, we're going to line them up to the far right side. It's easier to always put the one that has the most numbers on the top, just in general. And we know that we moved it over 1, 2, 3, 4. So in the end, we will move it back 4 places. 5 times 8, 40. 5 times 9, 45, plus 4 is 49. 5 times 1 is 5, plus 4 is 9. Magic 0. 7 times 8 is 56. 7 times 9 is 63, plus 5 is 68. 7 times 1 is 7, plus 6 is 13. We add them together. We bring it back 1, 2, 3, 4, and we get our answer to be 1.485. Excellent. Does that make sense to everybody so far? Let's see a show of hands. Thumbs up if you are getting this. I see some thumbs medium. I'll take it. Lucy has a vegetable garden that measures 16.75 feet in length and 5.8 feet in width. What is the total area of the garden? What is area when we are doing that? How do we find area? Who can tell me? Fernando? Yep, length times width. You will be doing that forever and always. Forever and always. So our length is 16.75. Our width is 5.8. Once again, we don't line up our decimals. We line them up at the far right. We had to move it over 1, 2, but now an additional third. So it doesn't matter how many times we move it over or from what number. It still is always how many times we're going to have to move it back. So in the end, we're going to move it back 3 times. So 8 times 5, 40. 8 times 7 is 56, plus 4 makes it 60. 8 times 6 is going to be 48, plus 6 is going to be 54. 8 times 1 is 8, plus 5 is 13. We add our magic 0. 25, 35, 37, 33, and 8. So we get 0, 5, 11, 7, 9, which brings it over 1, 2, 3. So our answer is 97.15. Thumbs up if you agree. Thumbs up. We got a lot of thumbs up here. So this next one was a little bit confusing, but you will have aspect questions like this, so that's why we're going to do it. So we have this shape. So here's the picture of the shape. It's already broken apart into 2 sections. We just need to be able to find the area of each of the 2 sections. So first of all, we know that this is equal to 6.1, right?
Yes.
And this side is equal to 3.1.
Yes.
So how much is this remaining side equal to? Who can tell me? Gore?
3.
It's equal to 3. How'd you figure that out? How'd you figure out that it's equal to 3 inches?
Because 6.1 subtract 3.1 and get 3.
Exactly. He did. 6.1 minus 3.1. We get 3.0. Exactly. So he's already solved that that's 3. Now, additionally, here at the bottom, we have 6.9. And here we have 3 inches. So how much is this area? Does it even matter? Do we need to find it out? No. It's not important.
Not important.
We already have the availability to find here. What's the length of this side and the width? Just give me the 2 numbers, length and width. Who can tell me?
3.1.
Perfect. 6.9 and 3.1. Lastly, what about the other one? What's that length and width up there? What's the length and width of the top one?
3 and 3?
Yes, Miles, it is 3 and 3. So then we just do the math. So what's the answer for the area for the top one? What's the answer for the area for the top one?
9.
Let's see, Daniel, it is 9. And what did we get as the area for the bottom one? Who can tell me? Ito, what do we get?
21.39.
Yes, 21.39. We add those two together and we get 30.39, and that's gonna be our area squared. So that's gonna be our area squared. We just added these two together because they're two parts of the same figure. So we already have it. Be careful with our multiplying of decimals. Okay, this one's actually a lot easier and a lot of you guys freaked out. Izzy's incredible library has 9,440 nonfiction books. She wants to split the books evenly among 80 shelves. How many books will be on each shelf? What operation are we doing here, Daniel? Division. All we're doing is we're dividing 9, 4, 4, 0 by 80. It does not go into 9. It goes into 94 once. We're left with 14. We bring down... Well, actually, we bring down our 4, 144. It still only goes in once with 80. That's still going to bring us down to 64. We drop down our 0, and that's 8 times 640 evenly. So our number is an actual even 118. It's a pretty good inclination, seeing as we're dividing a whole number by a whole number. But it's still, you could end up with decimals. But we get a nice 118 for that. So I want you guys to try these problems on your paper. So we got the first one, 20.4 divided by 3. Which number is our divisor? Who can tell me which our divisor is?
3.
The divisor is the 3. Who agrees?
20.4. Yeah.
20.4. It's our 20.4. What is that 3 called? Who remembers what the 3 is called?
Divisor.
It is called what, Michelle?
Divisor.
Dividend. And we are trying to solve for the, who knows? Quotient. Excellent. So this first one, really, really easy. In fact, the first 3 are really, really easy.
Yeah.
The bottom one is where we might have our trouble. Okay, doing number 10. 3 goes into 2. It goes in 0 times. 3 goes into 20. It goes in 6 times. That's 18. 2. Bring our 4 down. It goes into 24. 8 times. But now here's the thing. We have to bring our decimal straight up.
It's 6.2.
So that's how our decimal works. 6.8. So we get our answer to be 6.8. Does it make sense how we just brought the decimal straight up? Let's look at the second one. 326.12 divided by 31. So 31 goes into 3 0 times. 31 goes into 32 1 time. By miraculous amount, it is 31. We subtract, we get 1. 16 does not go in. 161. That goes in 5 times. That is 155. We subtract that. We get 6. We bring down the 2, and it's an even 2 times. 62, 0. Now, our decimal was right there, which means our decimal just goes straight up, and it becomes 10.52. Exactly. All we do when we divide is our decimal goes straight up. Let's try it with number 12. Here, 55.2 divided by 46. I'm just immediately going to bring my decimal up because we already know to do that. 46, 0, 1, 46. That brings it to 9. 2, and I'm going to bet you, yep, it goes in 2 times, 92 at 0. So our answer is 1.2. Our decimal just goes straight up. The last one's a little different, though, so I want you guys to try the last one and then bounce around your ideas to me. So who can give me an idea of what we do here? What do we think, Fernando? I get the what? Yes, I moved the decimal point out of my operation. I cannot have a decimal point in my dividend. Is it okay that I have a decimal point in my divisor? Yes, but I cannot have a decimal point in my dividend. So I just move it over and I'm done, right? Yeah? I'm all good?
No.
What do I have to do then, Miles?
You have to move the decimal on the other one time.
Exactly. What I do to one, I do to the other. The decimal point is always at the end if we don't see it. I move it that way. Our new decimal point is right there. And then we simply do the division. So do it on your paper. 64. It does not go in here. It does not go in here. It does go in one time here. 64. We get 56 left over. 560, we bring that down, we get 8. Do you know what 64 times 8 is? Who can tell me 64 times 8? Anybody can tell me? 512, yes. When we subtract that, we end up getting 48. We now bring down our 0. 480, it goes in 7 times. So we know that 7 times 64 is 448. We do that subtraction, we get 32. Bring down the 0, and it goes in exactly 5 more times. So we get our answer for this one to be 18.75. On your paper, you'll have enough room to show the long division. On mine, I did not. But the important rule to remember is that your divisor can have a decimal, but your dividend that's the important rule to remember. The divisor, that's supposed to be an R. The divisor can have a decimal, but your dividend cannot. Miles' submarine sandwich is 1.5 feet long. He cuts it into 1/4 foot pieces. How many pieces will he have? There's 2 different ways we can go about this. We can go about it the 3rd grade way, but we're also going to go about it the 6th grade way. So, here's the 6th grade way. We have 1.5, and we're dividing it by 0.25. We move our decimal over twice. We move it over twice. How many times does 25 go into 1? 0. 25 go into 15? 0. How many times does 25 go into 150? 6. With 150, and we get 0. Here's the 3rd grade way we can do it. We know that this is 1 foot, and this is 0.5 feet. We want to cut it in 0.25 feet, which means we want to cut it in fourths. That means it would be like this. We cut it into fourths. 1/4, 1/4, 1/4, 1/4. And we get 6 pieces. So there's 2 ways to do that. I highly recommend the 6th grade way now that we're in 6th grade. Okay, now this one again. Let's try this one. So the first things first, what's our rule about dividends? What can they not have, Rafi? They can't have our decimal. So we move that over. We move that over. There's our new decimal. Now, 34 goes into 1. 0 times. Goes into 16. 0 times. Goes into 167. 4 times. 4 times 34 is 136. We subtract that, we get 31. We get 312. That goes in 9 times. 9 times 34 is 306. We get 6. 68, it goes in exactly 2 times. So, we get 0.0492. Next one, we have 8.4 divided by 0.02. Yet again, we need to move our decimals. 1, 2, 1, 2. Our new decimal goes there. This is really easy. How many times does 2 go into 8? Number of fingers. Number of fingers. Yes, we see 4. That is 8. We bring down our 4. Number of fingers. How many times does 2 go into 4? Number of fingers. Excellent. 2. It's exactly 4. Here's where a lot of you had a problem. You forgot to bring down that last 0. We have to go until that decimal point. How many times does 2 go into 0? Number of fingers? 0. So our answer becomes 420. On a separate sheet of paper, solve these 4 problems and tell me which is not like the rest. Which does not have the same quotient as the rest. That's your hint. That 3 of the 4 should have the same quotient. Let's look through. This first one should be easy. 49 divided by 7. 49 divided by 7. Who can tell me it? Let's see everyone at the same time. 7. Yeah, we know that one. What about 4.9 divided by 7? What did we get for that one? What did we get, Romario? 0.7. What do we get for this next one? 0.49 divided by 0.7. What did we get, Gore? 0.7. What about this last one? 0.049 divided by 0.07. What do you get, Miles? 0.7. So which one's different? The first one is different. So the first one is different. One thing that you can tell, here's a hint. This one, they have exactly the same dividends, but they have different divisors. So you know something's going to be different between one of those two. We only have to check it against one other to make sure that it has the same quotient. So you wouldn't even need to check all of them, and you could just look at them. But anyway, that's how we do that. Now, here's another one. A lot of you got this wrong. When we do subtraction with decimals, what do we have to do? When we do subtraction with decimals, what do we have to do, Fernando? Line up the decimals. Thank you, Fernando. But what about this one? I don't see a decimal here. What do I have to do, Daniel? I add one, so I just do plus decimal? Excellent. How do I add it, Daniel? Exactly. So I add it to be 0.00, and then I subtract 16.98. Exactly. So a lot of you forgot to line up the decimals with subtraction. A lot of you put the wrong one on the top and did the wrong subtraction. So 0 does not work. We got to borrow. So this becomes 6. This becomes 10, which becomes 9, which this becomes 10. We get 2. We get 0. We get 0. We get 8. Our answer is 80.02. Excellent work, you guys. Okay, this one should not have been as hard as it was either. So we have a hat. That costs $10.95. We also have a really ugly t-shirt. It only costs $14.20 because it's really, really ugly. But then we have our nice handy dandy $50 bill that we're going to buy both of these things with. It's asking me, how much will I have left? How much will Brendan have left if I pay for both items with my $50 bill? What's the operation I'm going to be doing here? Who can tell me, Malia? Addition? That we could be doing that. Yeah, what else could we be doing here? Subtraction. So there's 2 different ways that we can go about this. So there's 2 different ways we could do it. We could do it by subtraction separately twice, or we could add the products together and then subtract them. So whichever you choose to do, just make sure you remember to do the final subtraction. Let's just go about it the double subtraction way. Here, this becomes a 4, 9, 9, 10. 10 minus 5 is 5. 9 minus 9 minus 2, we can't do that. It becomes a 19. This becomes an 8. 19 minus 9 is 10. Minus 2 is 8. We drop our decimal. 8 minus 4 is 4. 4 minus 1 is 2. We get our answer to be 24.85. It works the same way if we did it the other way. So, in this situation, we have pears. They cost 92 cents per pound. So these pears, they cost 92 cents per pound. And then we also have apples. And these apples cost $1.10 per pound. So Gloria bought 3.75 pounds of pears and 2.1 pounds of apples. So we have to see how much she spent in total. What does that word total indicate again? Who can tell me what the word total indicates? Romario. Yeah, in math. Yes, it means the answer. What were we doing to get the answer? What was our operation to get to total? Our operation for total, Rafi? Addition. So we know that by the end of it, we're going to be doing addition because we see the word total. So she bought some amount of pears and some amount of apples. How much do the pears cost? How much do the pears cost?
92 cents.
Yeah, so they cost 92 cents. And she bought 3.75 of those amount, that many pounds. What about the apples? How much do the apples cost? Jasmine says $1.10. And then she bought 2.1 pounds of that. So we're going to need to find out how much she spent for each and then combine it. Also, as a helpful trick, this ends in a 0, so just move it over. I don't want to have to move my decimal over twice that ended in a 0. We can just pretend that 0 doesn't exist. Who has the answer for how much she spent for pears? Who has the total answer? Daniel? Perfect. She spent $3.45. Who has the total answer for how much she spent on apples, Gore?
$2.31.
Perfect. $2.31. All we have to do is add that together. 345, 231. We get 675. So our answer is $5.76. We know that we have to do that addition in the end because they're total. And we have to find out how much she paid. And you pay per pound. Remember, per means each. So, per means. So, same thing that we do here. We just make sure we line up to the right. I always like to choose the one that has more numbers to go on the top. However, they both have the same. So, I'm just going to do 3005, 2504. I moved this one over 1, 2. I moved this one over 1, 2, 3. In the end, I'm going to move it back 5 places. So do this on your paper and then move the decimal back 5 places. If you notice, there's 4 numbers in each of these, yet I only have 3 rows. Normally, you have the same amount of rows as you have numbers in a problem. But when you have a 0, it's just going to be an entire row of zeros, so we can just skip it. It was the second one, so instead of 1 magic 0, I added 2 magic zeros. Anyway, we get this. We add it all together. We get 75.2452. It's got a 0. It doesn't matter. Last problem. We have 0.6, and then we add 0.0024. The only important thing is we need to move our decimal place out of our dividend. How many times are we going to be moving that decimal place then? Who can tell me, Daniel? 4. We move it. 1, 2, 3, 4. We do the same on this side. 1, 2, 3, 4. Excellent. So that's where our decimal is. Let's do it together. 24 goes into this. It goes into 60 twice. That is 48. That is 12. 120. It goes in 4 times. That's 120. And then here it goes in 0 times. So we get our answer of, it goes in 5 times because I'm being dumb. It goes in 5 times, and we get our answer of 250. Excellent work.